we will continue with practicing of transformations of graphs, but before we start practicing, before we start doing some questions, let's first revise what we should know, what we should memorize, what we should understand generally from transformations of graphs. So, we have to be able to recognize what type of function is. Is that parabola, cubic function, hyperbola, truncus, square root function, whatever. Then we have to know basic form for that function and standard form that includes all transformations that we can apply to basic form. What transformations we are talking about? We have horizontal translation, vertical translation, dilation from x-axis, dilation from y-axis, reflection in the x-axis, reflection in the y-axis. So these are basically key elements, key things that we have to put all together whenever we have to sketch some graph or to analyze some graph, whatever. Now, how to apply all of this? Must be some logic, some steps or things like that. Yes, there is. So, always, whenever you have question, always try to recognize what type of function is that. That should be our first step when we have a question to solve. Is that hyperbola, truncus, square root function, whatever, but we have to be able to recognize and clear to say to ourselves, yes, I'm working now with hyperbola, and then makes things much easier. Now you have to bring all knowledge from hyperbola to concentrate and to put on that question. In the second step, you have to check is your question, is your equation, is in standard form of that function. Let's say it is have hyperbola, if your question is in standard form or not. Here you have to be a bit careful, and of course when we start practicing questions we will have different situations and it will be much more clear, but at the moment what you are looking when you checking if your question is in standard form, you are actually looking the position of x in your question. Position of x in your question, in your equation, must be exactly the same as in standard form. The next thing that you have to look when you consider is it standard form or not, you have to understand mathematical operations involving with x. And once when you are confident, then okay, you will say yes, it is in standard form, or if it's not in standard form, then maybe just a few steps of simple algebra needed to change it to standard form, and then we can go on step 3 or 4. I put here 3 and 4 like 2 steps because there are too many things here that we have to consider. So in this step 3 and 4 we have to check for asymptotes, and we have to understand, we will think about asymptotes only if our question is hyperbola or truncus, while square root function, circle, parabola, hyperbola, they don't, cubic root function, cubic function, they don't have asymptotes. So only for those two we have asymptotes. Starting point, of course, only square root function, we can say just on one very simple way that it has one starting point. So we will think about that if we have square root function. Where is our starting point? What are coordinates of starting point and things like that. Turning point, of course, if we are talking about parabola, then we have to consider turning point or point of inflection if we are talking about a cubic function. Once, when we find those critical points here, then we can check our function for reflection. Remember, there are two reflections, reflection in the x-axis or reflection in the y-axis. And finally, when we are confident with reflections, then we can start sketching graph. When we sketching graph, basically we are sketching one of those basic graphs, but considering all those points. Anyway, when we're talking, it's not really easy to memorize, so better we will start practicing with this paper. There are heaps of questions here. I don't know for how many we can go today, but we will start slowly, question by question, and later on I may choose some more complex questions to do, and easier questions, of course, we will be able without my help to do it. So question 1, we have to sketch the graph of the function y equal 1 on x minus 2 and plus 1. So, okay, this is our question, this is our equation. We have to sketch that graph. First step, we have to check what type of function is this. How to check it, how to know. You don't need to memorize too much. You are memorizing just a few things there and then looking. Okay, is this function can be truncus? No, why not? Because simply x is under power 2 in truncus. But our x is not under power 2. Our x is just in the power 1. Okay, can this be this function? Of course not. Because here we have square root of x, here we don't have square root of x. So what else? Parabola, already we know that it can't be, so must be hyperbola. Okay, we finished with first step. So this is hyperbola. Second step, is this in standard form or not? Yes, x have the same position. Minus, plus or minus some number, plus or minus some other number, some number on the top. So everything is perfectly fine, matches to each other. So this is in standard form. Step 3. What we should consider here? We should consider asymptotes, as we are talking about hyperbola. So, asymptotes for hyperbola are those two numbers. In our question, position is here for those two numbers. This is horizontal translation. Don't get confused. Any number added or subtracted from x is always horizontal translation. In any function, here added or subtracted from x, horizontal translation. The same thing, the same thing, the same thing. So for any function, this is not hard, this is very easy to memorize and to understand. Okay, if this number is horizontal translation, moving that graph to the right or to the left, then we have vertical asymptote, and this number should be vertical asymptote. Then write equation for vertical asymptote. And vertical asymptote then is, x is equal, always opposite sign of this number, because if it's minus, this is going to the right, and we are going to positive side for 2 units. So this is vertical asymptote. This here is vertical translation, and moving the graph up or down. So must be horizontal asymptote. Epsilon, y equal 1. Okay, now we have asymptotes. We know that is in standard form. We know we are talking about hyperbola. The next step is to check for reflection. Is there any reflection? Here plus, no, so it will be like this. And now just to sketch. At the moment, we wouldn't consider x and y intercepts. We will focus a little bit more on how to apply transformations. So, asymptote x equal to 1, 2, vertical asymptote, and y equal 1, horizontal asymptote. Always write equation of asymptotes. X equal 2, y equal 1, because our teachers are taking off marks if we miss that. And what we have now? We have this graph here to place in our asymptotes. And of course we have this quadrant. And we have this quadrant here. And that's it. That would be graph of that function. It's not really hard, just a little concentration and everything should be okay. Okay, the next question 2. We have equation y equal 3 plus 5 on x plus 1. And we have no reason to go on any different way, we have no reason to guess anything, simply we are following the same procedure what we did in this question here. Of course, again, we are talking about hyperbola. Now, is this hyperbola in standard form or not? Well, I don't know. Obviously, yes, it is. Why? Because, look, this number here, but in standard form, that number is not there. That number is somewhere here. But really doesn't matter, because 3 plus, I don't know, let's say 8, or 8 plus 3 is the same thing. It's the same thing. So really, this doesn't matter where is here or there. So we can say standard form. You don't need even to work anything on this to change it to standard form. Simply, you have to recognize this number is like k in standard form. And when we state that this is hyperbola in standard form, of course, then we have to look for asymptotes. And obviously, horizontal translation, that is vertical asymptote, x equal minus 1, always with opposite sign. And 3 is vertical translation, but y equal 3 is horizontal asymptote. Is there any reflection? We are not looking this sign, don't get confused. We are always looking sign in front of this major part where x is. So, plus no reflection, simply we can sketch straight away this graph without any problem. y equal 3, 1, 2, 3, minus 1, and we are plotting that graph within our asymptotes, and everything is perfectly fine. We have graph of that function. Question 3. Okay, the same procedure, the same concept to recognize type of function. Of course, we already understood how to do that. So we are talking about hyperbola. Is it in standard form or not? Yes, it is. X asymptotes for hyperbola, and we have horizontal translation 4 units to the left. So equation x equal minus 4 will be vertical asymptote. Vertical translation 2 units down, so we are talking about horizontal asymptote, and equation of horizontal asymptote y equal minus 2. A reflection, yes, because we have minus in front of this major part in our equation, so we have reflection. And now we can sketch our graph. Asymptotes, x equal minus 4, minus 1, minus 2, minus 3, minus 4. So vertical asymptote. Horizontal asymptote, 2 units down, y equal minus 2, minus 2, and if we didn't have reflection, then we should place this curve here, but as we have reflection, so this part will on the top in positive y-axis, and this part coming down here. Just now I am correcting one thing, and to tell you, because usually teachers are taking off marks if this asymptote and graph are not sketched correctly. Because while I'm correcting this, I was sketching somehow like this, my graph. So here I'm not indicating that, sorry, not my axis, it's here, and if I make like this, I'm not indicating line x equal minus 4 that is an asymptote to this graph, because my graph doesn't approach to that line anymore. From this point, let's say, start going away from there, and that's why don't sketch like this on your exam or your test. Always a little bit slow down here to make your graph really to approach to this line. Anyway, this is a graph of that function. Next question, which you want to pick? Let's say question 5. We will take question 5 because question 4 is just normal hyperbola. We already did this, but we will do question 5. Question 5 is y equal 1 on 2x plus 3. Why I chose to work with your question 5? Because it looks like a little bit different than this form here, because here we have plus minus h, but here we have nothing, and also there is one number here, 2, in front of x that multiplies x. Maybe we can't claim that is like 100% in standard form. Maybe just little adjustment here needed to get to that form. It's not really necessary to do that, but anyway, better to try to understand the importance of that formula. If we adjust this, we can write 1 on 2 x and plus 3. Okay, now we have our relation factor. We have vertical translation, it's okay. Here we have x like this one, but we don't have h. So if we don't have h here, if we don't have any other number, so we can claim that horizontal translation in this example is equal to 0. So no horizontal translation. If no horizontal translation, if we are not going on that way or on this way, we are staying here, then vertical asymptote is x equal 0. Vertical asymptote. And horizontal asymptote, of course, vertical translation, that is y equal 3. We don't have reflection, so basically to sketch this hyperbola, we have y equal 3, 1, 2, 3, and x equals 0. This asymptote here, we are sketching this graph, and simply again be careful with this, and something like that. So take care about this thing here. No horizontal translation, vertical asymptote is equal to 0. Also, this, when just x here, you can consider, if it's easier, like x plus 0. So what is x plus 0? X plus 0 is nothing else than x. So obviously, h is 0. Okay. That was question 5, and now we will continue with question 6. So question 6 is to sketch a graph of y equal minus 3, 1 plus x. Again, talking about hyperbola. Is it in standard form or not? We can claim this that is in standard form because 1 plus x or x plus 1 is exactly the same thing. So we don't need to do almost anything here, just to go for asymptotes to see asymptote. First of all, we have horizontal translation, 1 unit to the left. So our vertical asymptote will be x equal minus 1. Of course, 3 is dilation factor, but we are not really interested that much in dilation factor at the moment. Maybe in later sessions, later questions, we will discuss a little bit more about dilation factor, but today it's really important to know how correctly to apply this concept. So, vertical asymptote is x equal minus 1, but what is horizontal asymptote? Remember, horizontal asymptote is actually vertical translation. This number here is vertical translation. So, vertical translation is number that added or subtracted from this major part. But what is in here? Nothing. But what is nothing in mathematics? Nothing in mathematics is 0. We can write nothing, but we are writing 0. If vertical translation is 0, so this graph doesn't go up or down, stays the same, then y equals 0 will be horizontal asymptote. Reflection, minus here, yes, there is reflection. This part going there, that part coming down. And just to make graph, we have x equal minus 1, vertical asymptote. Don't forget, sometimes I am not writing the equations of asymptote because I am trying to save time, but don't forget, whenever you draw asymptote, you must write its equation. Otherwise, you will be cut with mark. And we are going in this quadrant here, so graph will be like this, and this comes down, and it's gonna be like that. So, graph of this equation. That was question 6, and we will continue then with question 7. And question 7, equation is y equal 1 x minus 2 power 2 plus 3. So, what we can say here? Is it hyperbola? No, of course not, because we have power 2, power hyperbola, x is power 1, and it's really not hard to see that we have truncus. Is this truncus in standard form or not? Yes, it is x some number power 2 and plus or minus some other number. If it's in standard form, then the next step is to write asymptotes. This is horizontal translation, 2 units to the right, and the equation of vertical asymptote then will be x equal 2. The vertical translation, 3 units up, and horizontal asymptote will be y equal 3. Is there any reflection? No. And we can sketch graph. X equal 2, 1, 2, vertical asymptote, and horizontal asymptote y equal 3. And we have this truncus, so like that. Exactly the same of what we did in previous questions for hyperbola. We are following the same concept, simply looking the equation that we have, looking what we know, putting them together and sketching graph. That was our question 7, and now we are moving on question 8. Question 8 is y equal minus 3 x plus 1 squared plus 1. No need too much to talk. Straight away we can see that we are talking about truncus, and it is in standard form. Then x equal minus 1 is a vertical asymptote, and this number here, y equal 1, is horizontal asymptote. Do we have reflection or not? Yes, we do, because minus in front of this major part are giving us reflection in the x-axis, and we can sketch graph. Minus 1 plus 1, and instead to sketch it like this, we are going down because of this minus here. They're telling us that this graph is actually reflective. And we have this truncus. Yeah, one more question of this sort. that is question 10. Similar like when we discuss about hyperbola, we have here one very similar question, but anyway, let's start to follow this concept. Of course, power x to the power 2, so we are talking about truncus, but is truncus in standard form or not, this equation? Again, we're looking this, and that looks a bit different, but it's not really a big difference. Because why? Remember, x, we can write x plus 0 or minus 0, whatever, to the power 2. So writing like this, we have this. We have just x squared. So basically, for this equation, we can claim that equation is in standard form. Obviously, here we can see that h is actually 0, so there is no horizontal translation, and that means vertical asymptote stays on place where basic form has it, that is that x equal 0. So x equal 0 is a vertical asymptote. Horizontal asymptote is actually vertical translation, 1 unit up. Be careful, always I have to remind you on this, always you are considering sign in front of number, not after number. Because I'm telling you this, because I know sometimes students making mistakes, and if they see minus here, they are thinking that vertical translation is 1 unit down. No, this sign here is important. Plus, this sign minus is for that part there. So be careful not to make that mistake. That's why we will come back now here. So we have 1 unit up vertical translation, and equation of horizontal asymptote will be y equal 1. Do we have reflection or not? No, definitely not, because it's plus. And a very simple graph, just one asymptote, horizontal, of y equal 1, and we are placing this graph here. Here, of course, because if you know that this graph is a y equal 1 on x, here we have 2. This is just dilation factor, little bit stretching or pushing closer these two lines to y-axis. But what? When you compare, suppose if here was 1. So if you're looking just this, basically that is that graph. Because 1 on x squared, 1 on x squared, that's that graph. But you are adding 1 unit to that graph, so you are pushing that graph up for 1 unit. And that's why we have asymptote at y equal 1. We will skip question 11 because it's just normal truncus, I mean basic for truncus. Only we have the dilation factor of 3, so it's not really necessary to waste time. Better to go on question 12. is y equal square root x minus 2 and what is this, plus 1. Okay. So, following the same concept, we have to recognize type of function. Of course, we can't miss it. This is square root function, and yeah, then it is in standard form. There is no anything I need to do. And then for square root function, of course, there is no asymptote, so we are not looking about that. We are not thinking actually. Turning points, we also know that a square root function doesn't have turning point. Simply ignore it. And starting point, yeah, we define this as a starting point, and yes, it is somehow our graph starting from that point. So we have to determine the coordinates of starting point. That is our first step when we're working with a square root function. So the coordinates, because what we have here, when we compare basic form and this one, we have 2 units translation, horizontal translation of 2 units to the right, because minus here. So 2 units to the right, and we have 1 unit vertical translation is 1 unit up. So the coordinate of our starting point then will be 2 on x-axis and 1 in y-axis. Now we can make that point x, y, so 2 on x-axis and 1 up, and we are here. Basically what we are doing here, we are actually moving starting point from basic form, which is here. We are moving in another location, another position here, determined by those 2 numbers, by horizontal and vertical translation. Is telling us actually where the new point is. And now simply, as we don't have reflection any, simply plot, sketch a graph that is basically this graph, but only shifted a little bit to the right and up. Basically this is techniques of sketching a square root function, but anyway, we will see a few more examples, maybe to learn a few more things about this graph. So we will move to example 13. And example 13 is y equal to root x minus 1. Basically, we are going on the same way. It's square root function, and to determine coordinates of the starting point, we are looking for horizontal translation and for vertical translation. Okay, vertical translation is easy to see. That is minus 1. Minus 1 unit, so I mean 1 unit down. But what about horizontal translation? Of course, there is no horizontal translation. So that means this point doesn't go anyway from y-axis. It will be somewhere on y-axis. How to avoid confusion, like we had in hyperbola in truncus, to avoid confusion with this, when you have just x, simply this is x plus or minus whatever 0. This is the same thing, and of course now we can see that horizontal translation is 0. Anyway, our coordinate of our starting point then will be 0 and minus 1. We don't have reflection, and very simply to sketch that graph. So minus 1 is here, let's say, minus 1, and then as there is no any reflection, simply we are sketching that graph. Here that was question 13. Now we will see question 14. Question 14 is y equal 3 minus square root x minus 1. Square root function, yes, it is in standard form, only again we have this number before the major part, but we said doesn't matter, this number can be here, can be there, basically is the same. Then we have to see what starting point is. We have horizontal translation, 1 unit to the right, so x coordinate will be then 1, and 3 is vertical translation, so vertical translation is 3 units up. This is our starting point. Is there any reflection here? Yes, it is. Our reflection is here because we have minus in front of a square root, so we know that that is reflection. And reflection in the x-axis. So we can start sketching that graph. One unit, 3 units up, 1, 2, 3. So new position of our starting point should be here. And now, if there is no reflection, then of course our graph would go like this. But as we have reflection, then our graph doesn't go on that way, going on the other way, and this will be graph of that function. Here I would stop for a while with examples, and to stay a little bit in this graph for when we have a reflection. We learned a few sessions ago, I don't know, maybe last session, we had actually one point with some coordinates, and we said if this point reflected in the x-axis, then that point will be somewhere here. Yes. What we had here, we had starting point with coordinates 1 and 3 here. We also had a reflection in the x-axis. But this point we didn't reflect. That point stay on the same place. We didn't make that point here and to plot our graph here. So this is definitely wrong. This one is correct. Why is that? Simply because, similar like what we discussed with Kramkas and hyperbola for asymptotes, that we are not moving asymptotes, we are not reflecting actually asymptotes. Here also we can't reflect that point. Basically, we have reflection in that line. We have reflection in the line that passing through that point, and then we are reflecting our graph. So remember, this point here we are not reflecting, and everything else, all other points of that curve that we are reflecting, we are not reflecting really around x-axis, we are reflecting them about that line. So this point and its reflection will be somewhere here. Anyway, let's see another one example, because with this reflection, I mean, things are quite simple. But then we have maybe two reflections, then sometimes people getting confused. Okay, I'm turning this curve on that side, then after that on this side, then after that on that side, so where is my curve at the end? To avoid those problems, we will take another one example here, and I will try to help you to get better confidence. I mean to get accurate sketch anyway. Let's say if we have y equal 3 minus square root x minus 2. Sorry, I will make minus here also, and here I will make plus. Now, this equation, even not in a really exact standard form, maybe just little adjustments needed to have exactly the same, that is that minus, but now x minus 2. So now we have exactly the same standard form. We will do some examples a bit later when we are changing our equation to standard form, but this one just to show you a bit how to work with reflections. Obviously, our starting point is 2 and 3, but we have two reflections. We have both reflections actually in the x-axis and reflection in the y-axis. In that case, to avoid to keep in your head too many different graphs to come to final one, then simply plot your point 1, 2 and 3 units up, 1, 2, 3 units up, so your starting point should be somewhere here. And if we don't have any reflection, that is first thing what we have to put in our head or to put in paper. If we don't have reflection, then simply our graph is this one, starting from that point. Now, we have reflection in the x-axis, and simply reflect that graph in the x-axis. In that case, we would have this line here. But again we have reflection, but now reflection in the y-axis. Then reflect that line in the y-axis. And again be careful, always we have to start from that point. We can't go on the other side. And then this would be graph of this function. So if this make you a problem to turn in your head, simply plot this graph, reflected once, then reflected again, and you will get graph that you need. Don't get confused. I mean, we choose first to work with reflection in the x-axis, and after that with reflection in the y-axis. We will get the same curve, of course, if we go on the other way. Let's say if we reflect this graph first in the y-axis, and then to reflect that graph in the x-axis, and we are coming to the same curve. So the order of reflections is not really important when you're sketching graph. Maybe will be important in some cases for something else, but for sketching graphs is really not important which reflection first to choose. Yes, so with square root function at the moment, that is all. Remember, with reflections we are reflecting our curves about those two lines. Basically, what is this? And what is transformation by the end giving us? What we are transforming? We are not really transforming curves. We are actually transforming our system x and y. And if you move this system for 2 units to the right and for 3 units up, then this starting point will come exactly where your curve is. And that's why those two lines that I sketch to that point, they are just playing exactly the same role what x and y have here. So basically, those two lines are like new xy system where you can place this graph. Okay, we will continue. So we had question 14. We will go back to our exercise paper, and we will continue with question 18. Question 18 is y equal 1 minus 2, 3 plus 2x. From this paper that we are going now, somehow from question 18, actually from this question, we are coming in one a bit, I would say, advanced techniques to sketch graphs using a transformation method. In many schools this year, teachers probably wouldn't use that advanced techniques, but in some schools definitely they will set questions like this. But definitely next year in Methods 3 and 4 you have to be quite confident with this. So that is much better. Learn it now, get some ideas in case if you have in your school questions of that sort. You should be fine, but definitely next year then you will already have too many things to learn. At least this will be okay. So what I'm talking about here? I'm talking because when we're following the same procedure, function type, we can recognize we are talking about hyperbola, that's not a problem, but is it standard form or not? Or if you ignore that and if you go straight away for horizontal translation, for example, and if you say that horizontal translation 3 units to the left, because we have plus 3, then definitely you would be wrong. Why is that? Because not in standard form. This equation not in standard form, not in that form. And once again, when you are looking for standard form, we always have to take care about position of x. So in standard form, we have just x. So there is no any number that multiplies x or divide x or whatever. We have just plus or minus some number. But here situation is different because our x multiplied by 2. And this makes big difference to that because here we have like a double x, not just x. So to come to standard form, we have to remove 2 from x. We have to take that factor out of x. Of course, we can achieve that when we take 2 as a common factor, but only from denominator, only from expression with x. We shouldn't do anything with that number or with that number at the moment. Then our equation will be 1 minus 2, and when we take 2 from here, then x plus 3 on 2. Of course, now we can see, okay, we can simplify this by we need 2 here and 2 here. So cancel out that, and y equal 1 minus 1x plus 3 on 2. Now we have exactly the same form as this one here, because x is on the right position, only x, there is nothing else. Here we have some number added or subtracted from x, that is actually horizontal translation, and now we can sketch graph where we have all necessary information. So our vertical asymptote equation is x equal minus 3 on 2, and our vertical translation or horizontal asymptote equation would be 1. Yes, we have reflection, but not first asymptotes. So 1, that is y equal 1, x equal minus 3 on 2. So a little bit model this one. X equal minus 3 on 2. And we are sketching this graph, but that graph reflected. So this up, and this is in this quadrant here. And that would be graph of this function. Yeah, we will continue with a few more examples of this sort because little algebra sometimes needed to adjust this equation. And maybe a good example would be next one, that is example 19. And example 19 is y equal 4 minus 1 3x on 4 plus 4 over 2. So, trunkas, but trunkas not in standard form. So we have to perform some algebra to make it to be in standard form. Okay, we have 3x on 4. So we understand that we need just x here. We have to take common factor, everything what is not x. So what to take? To take just 3, then what to do with 4. You have to understand 3x on 4, we can write 3 on 4x. This is the same thing. And now we are taking 3 on 4 as a common factor from denominator. Then y equal 4 minus 1, 3 on 4 and x plus 4 divided by 3 on 4, close bracket, over 2. Did I make some mistake here? Yes, I did. I did mistake. What mistake? Okay, with this one is perfectly fine. We said we have to take 3 on 4, so x here. This is also perfectly fine because only it's not calculated, but don't worry about calculation. But where is mistake then? Mistake is in here, or if you like, here. Why is that? Because 3 on 4 is on the power 2. Writing like this means that 3 on 4 not on the power 2 anymore. 3 on 4 is just normal 3 on 4, just on power 1. So mistake is here. I am talking about this because I know that plenty people, unfortunately I have to say plenty, too many of you, like, you understand this, but anyway, when you write, when you do your work, just like rushing, okay, I am happy because I know to take 3 on 4 out, and you are taking 3 on 4 out, making power 2 here and jumping on next step, this is mistake there. So that's why I am talking about that. And in this way, if you write, you can't make that mistake, because now you are keeping 3 on 4 still on the power 2. Of course, now you have to adjust this to a standard form, so standard form doesn't have these big brackets, and you have to expand these brackets, and your equation would be 4 minus 1. And now when you're expanding, okay, wait, I'm expanding big bracket, so what? I have power 2 here, 3 on 4, so that is 9 on 16. And x plus, and here we have 16 on 3 and over 2. Okay, now we are very, very close to standard form. Maybe just one more step, because we have this number here that multiplies this bracket. If you don't like that to be here, simply because you have 1 over 9 on 16, that is a reciprocal of 9 on 16, and it will be final equation 4 minus 16 on 9 x plus 16 on 3 to the power 2, and now we have standard form exactly what we need. Okay, now if you want to sketch graph, by the way, question is to sketch graph. We can sketch it, why not? And horizontal asymptote equation is minus 16 on 3. Vertical asymptote equation is y equal 4. And now we can upload those asymptotes. Y equal 4. Let's say if we make it somewhere here. Y equal 4. X equal negative 16 on 3. 16 on 3, that is a bit more than 4, it is 4. So we are going on negative side, let's say somewhere here. And now we are sketching truncus, but we shouldn't forget reflection. Truncus is reflected and going on this way. So that graph should be like that. When adjusting your equation to its standard form, sometimes you have to be ready for maybe 2-3 steps to apply algebra. And of course you have to be careful when you work with algebra not to make some mistake. Okay, let me check what question